Rhode Island's pilot deep energy retrofit project with National Grid. It's what we've essentially done is take a pretty ugly 1962 ranch house that was condemned, the septic system failed, water came into the roof, and the people abandoned it for a couple of years. We built an exoskeleton around the entire house. I'm going to show you how to do that. So you're going to have an R40 wall, an R60 roof. There'll be below grade insulation that's going to be going in a little bit later date when you put the septic system in. At the end state is you'll be able to heat each one of these units with a candle and a toaster when all is said and done. Literally get that down to just about nothing. And this will be going on for the remainder of the National Grid's portion of this should be about $60,000 bucks. That's the max incentive for it. This is a two-family house. They were granted, I believe, about $1.5 million is the combination of inputs that came up to that amount of money. Kind of see on the outside of the house is 1.5 inches of Atlas Energy Shield insulation. Okay, the whole house is wrapped in that. That's 1.5 inches of Atlas Energy Shield insulation.
And you put that on the outside of the existing, like outside of the house? Or?
Not quite. But what this does, and I'm going to show you what we did. There's two things we're going to look at, from the inside out and the outside in. You'll be able to see it better from the inside. But right, keep in mind that the whole outside of the house is, and then we put that tape, various forms of tape. So this is your drainage plane, and this is also taking care of all your thermal bridging. And your average house over there, aside from the glass, leaving out the windows, 20% of that house has no insulation in the walls. That's where all your plates, studs, jacks, kings, and headers are. No insulation in that. So you have a 2x4 has an R value of 3.5. And the house you're going to go home to tonight, between your drywall and your exterior sheathing, there's not a stitch of insulation. So 20% of that wall, headers, jacks, studs, no insulation. And then you have the windows. Okay? An inch of this wrapped around the house, properly detailed, is twice as good as 3.5-inch fiberglass bed insulation. So this alone on a house beats any conventionally built house. This also acts as an air penetration barrier, air sealing. So properly installed and taped, this will give you a great blower door test. This alone will do about double Energy Star. Foam, which we see on the inside, open cell foam, and this is where all the expense of energy efficiency and green building is. It's in the building envelope. Everything else is the same. After you get through the building envelope, nothing else really changes. That's just a matter of selections.
So is that like that insulation twice as expensive, or how much?
Foam, it's about 2.5 times the cost of fiberglass, is what it amounts to, but it's about 10 times better, literally. I mean, the effectiveness of it is geometrically greater, logarithmically greater.
Is it made of ice?
This is not. I'll give you a copy of that. This is different than the icing foam on the inside we're going to see in a minute. But just remember, this takes care of all your thermal bridging.
Is it guaranteed to last?
Yeah, this will last longer than us. It's conventionally called post and beams. All it is a center stick with this wall and these 2x8s running up. This is the original house. Those are the original boards from the original roof. Okay, so it had about a 212 pitch on the roof, which is pretty low. That was the style in 1962. Resting on this main post here in the middle, the center stick over the beam right down below. See the original 2x4 walls behind you with the original 1x12 roofers. We call them 1x12 roofers. So we had to put some plywood in for shear wall strength on the edges. Well, you're standing inside the original envelope. Now, if you continue to look up, you're going to see how we put a new roof above that. We created that cavity in there that's going to be filled up, and most of that will be filled with insulation. You also look at the window depth. We put another 2x4 wall on the outside of the house. So what you're going to see is you see some foam squirting through between those 1x12 roofers right there. The original wall is here. This is the original wall, basically. Then right here where my hand is the new wall. We jacked the whole house up. We put a 2x12 plate in. That's what you see when you saw outside. You saw the house hanging over the foundation. What that gives you is a whole new cavity here, 3.5 inches. That's filled with closed cell foam, R6 per inch. Not probably going to test it to that extent, but I believe it'll meet the European passive house standards. But you can only do, the one we did out of styrofoam and concrete that Rachel and Marion came, that was like a 0.8, 0.7, and had we got the little smokes out and really chased it around, we could have got to that at 0.6 air changes per hour, 50 pascals. That's super tight. At that load of the house, you start micro loading, you know, bodies, plasma TVs, toasters, you know, car chargers for your cell phone. That's providing enough BTUs to actually heat the house. That's a passive house. You're literally that tight. Warm temperature, the thermal mass of the house doesn't leak and doesn't get cold. So once this house is warm, it'll stay warm. So if you shut this house up in February and it's 65 degrees before in the afternoon, the next day you come in here at 6 in the morning when guys come to work, it'll probably be 65. It might drop to 64, but it'll just stay.
Wow.
Okay? Whereas a regular house is leaking every hour, you gotta change the air. You know, so it's constantly leaking. You've got thermal transfer happening all over the place. You've got hot air coming on, cold air leaking out over here. What we're finding in our houses are people are setting the temperature 3 to 5 degrees lower and feeling the same degree of thermal comfort. Just because the temperature of the mass of the structure is so consistent. So all these things start saving more money. So that's kind of the way it goes. But you can kind of see what we have there. The cavity, I call it the exoskeleton. We ripped it apart, and it was a mess in here a year ago. But the idea is we built an exoskeleton around the house to give you that cavity to support all that new insulation and thermal bridge. Any questions? Looking around, you can see what's existing. These are the existing old wood. We kept everything we possibly could. This, you know, 50-year-old wood is actually better than new wood, as long as it's dry. Then it's denser. The newer wood has longer fibers in it. It grows faster, much more susceptible to any type of weather, humidity type changes, which we've been known to have here in Rhode Island, in case nobody's not aware of that.
So they liked the energy efficiency features, but that's not how you sold it, correct?
Right. The number one driver for this is somebody's got to buy this, somebody's got to like it, and somebody's got to live here. You know, and people, there's very few people in this market that come in and say, I demand a super efficient house. That's just something nice to have. And a lot of people lost a lot of money trying to do that, try to build these greenhouses that no one actually bought. They spent too much money on them. Everything we do is to make them cost effective. You know, for example, I'll show you a picture of one we finished a year ago. Cost about $5,000 more to build, but the lady, she's a widowed school teacher, nice person, friend of the family. She saves about $2. It costs her $1 a day more to own the house. Amortized over 30 years. She saves $2 in change in utility bills every day. So it's a good deal. You know, and that's why, you know, we talking to the politicians is presently your underwriting situation is such that they don't recognize the value created. When you get a loan now, your underwriting standards are based on standards developed in the Eisenhower administration, literally. I mean, that's how we do financing residentially. Now, we had a whole problem with the subprime thing, we all know that to death, but now we've gone back to the 50s. And very few things in life are good to go back to the 50s, you know, just in general. You know, we're really on the leading edge of some of this stuff. Not to say I know everything, because I don't, there's smarter people, but we've got all these little projects in North Kingstown that we're kind of doing right now, and we're attracting a lot of business out of this. You know, being in a building depression right now, you got to differentiate your business product. So this is a win-win. It's good for the environment. I like it, and customers are knocking on the door a little bit.
Well, you're setting a great standard, and you're remarketing yourself.
Yeah.
You know, that's a great success story.
Yeah, and we are providing green jobs, if you will. You know, the guys, and I can take you up to EG, but we're training the guys, and they all get paid pretty. You know, they're all. You make pretty decent money in construction. You work hard for it, but these are all guys that can afford to buy these houses, you know, and live in them. Work not your average, not your labor level apprentice, but you know, your journeyman carpenters, electricians, plumbers. You know, those are good jobs that can't be outsourced. So skilled labor is important. So to be a green builder, I can tell everybody first you got to be a good builder. If you want to be a green carpenter, first be a good carpenter. If you don't have basic skills, I can't help you. I'm one of the biggest green jobs providers in the state right now, if you want to look at it that way. But it's all based on traditional skills that are further refined, and all the little extra things you need to do. But you've got to have a basic skill set to start. And you know, if you talk to like the Perkins grants that support a lot of vocational education in Rhode Island, getting cut. So I'm very active with the Builders Association and trying to make sure we get skilled labor trained up. You know, you have it with me, but I showed Marion a piece of paper that showed 3 houses in North Kingstown: a 1952 house, a current code-built house, and that house. The energy cost goes from basically $3,800 to $2,400 to $1,200. It's a little display we did. I should have brought that in there.
So you're cutting it down by a third, down to a third.
Yes, of an existing older house, your typical 1950s post-war rancher cape, based upon a 1,300 square foot model.